Okay, so yeah, thank you all for coming. I'm happy to be here as well. It's not like Bangkok, for those who remember. So yeah, I'm here to talk about mostly what we, the core development team, has been doing for the past year or so. We spoke a lot about Half-Life 26 in the previous HiveFest in VR. So now I kind of want to do kind of a recap of everything that's been built and figure out, well, basically run you through everything that's coming for that hard fork and kind of give you a sense of what what was the thought behind all of it. Basically, the idea was to really, it's not as flashy as the other hard forks where there isn't that many new protocol changes that are like new operations, new things like recurrent transfers, the convert function to allow you to like keep the peg stable and everything. It's way more of like UX improvements in the sense where you can actually get a lot more stability, a lot more scalability. Everything is much faster and much more, much better in a lot of hidden ways, let's say. So first, I'm going to talk about one of probably the biggest change, I'd say, which is OBA. So irreversibility has been a very big problem that we've had over like literally since Hive has been a thing. Because when you build a layer 2 applications, HiveMind or Half or things like this, it's tricky because you basically stream the blocks and you get the blocks onto your database and everything. The issue is that as soon as there is a revert, as in you get the blocks, so you apply all of your expensive changes, and then suddenly the blockchain is like, oh, actually this block got reverted because there was another block. You have to basically roll back, and that can take a lot of processing power and also a lot of development time, because you have to put that into your application. This is why all of the blockchain teams spent like literally months working on one block reversibility. It's basically a protocol change the way all of the blocks are processed, which allows us to basically have a block that's irreversible. Instead of having to wait 45 seconds, it's now like under a second in the optimal case. Which means that in the UX, it improves drastically. For instance, let's say you are on a community and you want to like subscribe to a community, you want to add a new post onto a community, etc. Before then, you would have to wait about 45 seconds to make sure for it to like actually reflect. And now it's going to be almost instant. So the goal of that is really to like bring Web 2 speeds into Web 3. So that's very exciting. Going through all of the things about like increasing the stability, increasing all of the scalability. One of the big changes also is block compression. As you guys may or may not know, right now when you run a witness node, it takes about 700 gigabytes and growing. I don't actually remember what the rate is, but it's multiple gigabytes per year, like 50, something like this. I don't want to say anything, but I'm not sure either. Anyways, it's a lot. And so that's an issue because as we grow, we cannot like properly decentralize if it costs too much to actually run a node, because then you run into what some other blockchains that I don't want to name, where you actually need to pay like thousands of dollars just to run a node. So block compression is going to be now literally reduces the block size by 2. So we have like twice as much room to grow. There is a bunch of other P2P layer improvements where P2P is peer-to-peer, which allows us to be much more efficient in the way the blocks are spread through the network, which increases the stability by a very big amount. And then a bunch of other performance improvements in the JSON processing. So that's most of what's going to work on the layer 2. So you can think about it like Splinterland is mostly JSONs. Most of the community is JSON. So yeah, that improves the blocks and the transactions and the way like basically the blockchain can process block in like a drastic manner, which again allows us to improve drastically everything. The idea really is to allow us to be ready for the next bull run and the next big scaling factor. Because we talked a bit about like Splinterlands and how they have like a huge amount of transactions coming in. But our goal is really to have like 10 sprinterlands, and that's why all of these improvements have been made. And yeah, in order to support all of that, there was also a lot of research that went into RC credits and basically all of the costs. You may be slightly upset about it because a bunch of operations will be more expensive, but it's also to improve scalability and make sure that we are not susceptible to DDoS and basically people spamming a lot of transactions, which results in like more bloat into the chain. And it's not going to be an issue anyways, hopefully, because RC deletions are coming. So RC deletion is like, I spoke about it last year, so if you saw my talk, it's basically going to be the same thing because not much has changed, except that now it's done. Something pretty useful, I'll agree. So yeah, RC delegation is pretty easy. It's basically the way you would delegate Hive power. It's the same thing. So you basically use your posting key, and you're like, I want to give you 1,000 RC, and there it goes. So it's done using the posting key. So that's actually quite an important part. It's mostly to allow people to basically build systems and basically an RC market where I envision that we could have websites where you can literally rent RC and be like, I'm going to do a very big NFT token launch, and so I'm expected to like issue a lot of custom JSONs. So I'm going to rent RC for like 2 weeks and then give it back. So yeah, it's basically going to be a secondary market as we grow. You can really see RC at the same way as like gas is used in Ethereum. It's really, right now you don't see that much value into it because we scale the chain so well. But as the chain is going to grow more and more, a lot of things are going to get more expensive, and so that's where it's going to come in. So there is no limit in the number of delegations that you can do, and you can delegate to about 100 accounts at once. So that's useful if you're migrating your project into like from like delegating Hive power to now delegating RC. RC is very important for projects because for the longest time, literally since Steam exists, whenever you had a project and you wanted to onboard users, you ended up in a situation where you want to onboard the users and you don't want to make them pay their account, or like pay like 15 Steam and now Hive. So usually to ease that, you basically delegate Hive to them. The issue is that then you encounter an issue where someone may come in and try to create 1,000 accounts and use that to like self-vote and do spam. And so literally all of the DApps, as far as I know, have had this issue where you want to onboard, but then you have to spend a significant amount of your time literally fighting spam. And you cannot not do it, because if you don't do it, then your reputation will be hurt eventually, because you're like, oh, actually you created all of these accounts and now they're using it to bot and everything. So yeah, that's going to be pretty exciting. And it's going to ship with hard fork 26. Some smaller hard fork 26 change. I was talking about it with Dan yesterday. The haircut rule is not actually a small change. It's going to change quite drastically the way the tokenomics of Hive works. But if you are not aware about what the haircut rule is basically how much HBD can exist compared to Hive in terms of price. And so what this means is that if too much HBD is printed, the chain will stop printing HBD. So that comes in the form of like post rewards, conversions, things like this. It's usually happened in times of bear market, but we decided to increase it that way we can actually deploy more capital. And now that HBD is much more stable, we feel more confident to increase it to 30%, which literally means that the whole Hive DeFi ecosystem can grow 3 times as large. So that's going to be pretty exciting. Although smaller UX change, I guess, users can now vote more often. So you know how you go on like a reading spree and you like reading comments and then you want to like vote a bunch of people. We've all been there. Now and like the chain stops you from doing that. Now the chain won't stop you. Also, you know when you vote someone and actually it was the wrong percentage, so you re-vote, and then you lose the curation rewards because the chain actually used to reset that through votes. Now that's no longer here as well. So that's a bunch of like smaller UX changes, as I said. And finally, I mean, last but not least, this is one thing for the Ledger. The Ledger application. Ledger is like a small hardware wallet, like the most known. Engrave asks for this change because in order to do a proper onboarding, you want to change the keys twice in the same flow, and before the blockchain could only allow to do it once per hour, so we changed that to 2. And finally, we added a bunch of virtual operations. That's actually going to be very good for Arkanj because he uses it to track most of the things. Yeah, it's mostly like housekeeping items, basically, where it's virtual operations that can go anywhere from like producers, witnesses missing blocks, or as far as stuff like, oh, you sent money to the DHF, what was the actual Hive to HBD ratio at the time, things like this. So yeah, basically, that's what I meant in the intro, is like this hard fork, if you look at all of the changes, you may think that the most interesting thing is actually RC deletions, but actually it's a lot of very big changes that are under the hood, and it won't look like it, but actually like we have a brand new engine that's going to allow everything to scale so much bigger and so much faster. And right now, it may not feel that important because we are in a bear market, but trust me, as soon as the bull market will come back, if it comes back, not financial advice, it's gonna really put us like in the forefront in terms of scaling compared to most of the other chains. And then you may be wondering, when is all of that coming? Tentatively, as usual. Because right now, like Gandalf is doing tremendous work and testing thanks to the mirror net and everything. That's also another very big thing that's allowed us to improve testing drastically. But yeah, if everything goes well, we have a tentative date for October 11th. And I guess I'll see you there. Do you have any questions?
Fun thing to do the questions. It's been a while. It's actually last time we had this thingy. It's the catch box. It was on first TeamFest, and yeah, it's super awesome because you can throw. And this is a good reason to ask questions because then you have to talk inside in the box. It's like a magic 8-ball, and then it will give you the magic answer. So talk inside the box, and when you're done, you can throw it to the next question.
Hi, it's APS Hamilton. Does the block compression mean immediately on the hard fork the chain will halve in size?
So actually, even before the hard fork, it can happen because the way the compression works is it's going to be on by default. So if you run the new version of the software, if you get basically new blocks coming in will be compressed automatically, even before the hard fork. So, is this working? Yeah. So if you have old blocks already stored on your server, you have 2 options. The easiest option is to shut down your server temporarily and just compress it. There's a compression tool that you can run separate from the main tool and just compress it down. You could also, of course, just resync from scratch if you wanted. But your old blocks by default will not compress on their own. You have to do something to compress old blocks. Right. So anyone running a serious node should do that at some point. Just make a copy of their blockchain.
Yeah, that's really cool. My witness stopped working because it ran out of disk space.
Yeah, I mean, it really is a lot of data. I mean, we have, actually one of the most active blockchains out there, right?
Yeah,
in terms of transactions, it's huge. So it was definitely, 2x doesn't sound like a lot, but as a guy running it, it matters a lot.
Yeah, well, if you want to run your own servers, you get a terabyte SSD, and with all the other stuff you got to run, like if you can't fit it within a terabyte, it's starting to be a problem because you need bigger drives and they're not so cheap and all that sort of stuff. So that's fantastic. Yeah,
if you're just running a straight node, a terabyte should be totally fine now for some time to come.
I've got just a quickie. I guess this is going to be a GitHub issue, which I'll raise afterwards, but I'll just bring it up here. The repeat payments, which I don't think are getting used. Yeah, I think after this, I'm going to put, and after HF26, I'm going to put. I've thought of an absolutely killer use for them, but it involves my one account receiving multiple payments, sometimes from the same.
Sounds very suspicious.
Yeah. And then I'm speaking on with my V4V hat on, so V4V app. So as soon as a payment comes in, I would then send it out as Lightning. And I'm Brian of London, by the way, if anybody doesn't know. And the recurring payments has got this restriction, which is that you can only have one recurring payment to a specific account at any given moment. So I'm just sort of putting this out there because I don't see recurring payments being used all that much, but this I know I can turn into a big use. So I'll stop. I don't know if there isn't really an answer. It's just, I guess, put it in.
Yeah, pretty much.
Microphone.
Microphone is, this one is not working.
Oh,
It is.
Is it?
Yeah,
Okay.
to get close.
Okay, never mind. Anyways, pretty much. There's no really answer to that. We actually spoke about it previously, and we have a way of doing it, but it's going to be in HiveFest 27.
I guess the question is, how difficult do you think it'll be?
Oh, not that difficult, honestly. I feel like it's, pretty much doable. We just have to do it. So it's going to ship in the next hard fork, probably.
So maybe we'll try to make the next hard fork a little quicker.
Likely. Jarvi.
All right, Jarvi. So blocktrades, you've done a lot on half, right? And so
Yes.
what's going to be happening now? Because you talked about HiveMind migrating to that. So tell us what's going on with half and HiveMind.
Yeah, sure. So there's a couple different things. So for people who don't know, probably most people here do know, half is basically our model for future development of pretty much all Hive apps. That's really where we want it to go. So kind of replace the current model where you write something that makes API calls to, basically you have to know the Hive API, and there's very limited in what kind of data you can get. And then you might have to create your own database to reorganize that data in your own application. And then when you do that, the resulting database is only something your app knows about and nobody else can know about. So it doesn't encourage reusability of features and things like that. And so one of the big things we really wanted to do with Half 2 is also get a lot of the processing that's currently inside the HiveD nodes outside of it, so that the HiveD nodes just focus on the core blockchain stuff and not all this other things that would be providing data for applications. So the idea is basically your HiveD node just processes blocks and transactions, and then it sends all that data into a half database server. And I know half the people are going to say, what is all this? But then the apps are talking to the apps talk to that database server, and that way all the load from those apps is no longer in the HiveD nodes. So the HiveD nodes can just chirp along as fast as they can and don't have to worry about getting overloaded. And this is huge. I mean, this is one of the problems a lot of blockchains have, is this kind of super loading of the servers. And it also, this gets to the point where you hear something like CryptoKitties slowed down Ethereum to a crawl. These kind of things won't happen with this approach. So anyways, as far as what we're doing with Half right now, so Half itself at the base layer is a new way to write your application. And the beauty of it is, even if you already got an application, it's designed to not make it difficult to switch your application towards using Half instead. So, I'm looking forward. I think we should see Splinterlands and Deluxe and some of these other second layer apps eventually move to Half themselves. But they don't have to right away. We still support all the API. But even there, we made some changes, because while you can still, the HiveD nodes still have the capabilities, the old API support for your applications, your legacy, I'm going to call them legacy applications right now, versus the Half application, you can also make the same API calls to the Half server, most of them. So that means most of your apps traffic API calls can go to a Half server instead of the HiveD. So again, even if you don't make any changes at all to the application, some of your calls you send to the Half server instead, you can immediately lower that load on the HiveD API nodes that have been out there today. And as some of you probably know, we've got, maybe 10 or so API nodes that are public. So we really want to lower that traffic down. And so with Half, the other part of this is not only does it take away the traffic from the HiveD nodes, the critical nodes doing the processing for the network, but it also has this other really beneficial effect, which is it's much faster. It turns out by moving this data onto a SQL server, these databases were designed for massive amounts of data, and this technology has been I mean, been created for like literally multiple decades, 30, 40 years probably. So this stuff is really, really good. It's really, really solid, and it's designed for high performance. And so what we could do with the Hive D nodes was it had like, it's been maybe a year or two been spent developing that stuff. So it was not anything like the kind of solidness and the performance that we can offer with the SQL Server, basically having all the blockchain data inside of it. So again, I know some of this sounds a little strange, but that's really, the half is really going to allow us to really scale up how many apps can read data on the blockchain and process it without putting any kind of stress at all on the nodes. So I guess finally, to answer your question, just finish part of it. Yeah. We initially moved the APIs that you would be most important to know. We've got the Get Block API, which gets the basic blockchain data. We now have that in half. That was one of the last things we really did. It was actually an oversight. I thought it was getting done earlier, and then I realized, it's missing. And then the other thing is the account history, because that's also the other really big one. So when you go to your wallet and you see all your transactions, you maybe go to a Block Explorer and see all those transactions. That used to have to require hitting up on a Hive D node, and really it's very expensive calls. And now that's pushed off to half. We've also done some other little like mini apps just to demonstrate how to make a half app easily, so you can look at the example app and then know what to do. So we did one. It's like a balance tracker app, so you can see how your balances of Hive or HBD have changed over time. And then we're also generating a new Block Explorer, which is open source, based off Hive half as well. So that's pretty much where it's going.
Yes, no?
Just bounce it off someone's head.
Just pass it down.
Is everybody speechless? No, I was curious, how you were saying that you said that some of you just touched upon it with the RC delegations. You said that some will change in weight, right? In how expensive they will become. And then you said, but can you just shine a light on that? Which ones are going to be?
That's probably me, I think.
Oh, okay, sure.
So one of the things we found when we were doing the calculations for how much operations really cost. So just so anybody's not clear, basically you probably know that different operations like voting versus posting or transferring have different costs in RC, but you might not know exactly what they are, because I don't either. And you could find it out, but it's just not something you do normally to figure out. But there's a few things you might know are really expensive. So one of the ones that's super expensive is account creation. And there's a reason for that. So these costs, when they were originally set, they were kind of set somewhat arbitrarily, but the developers back then made their best guesses about how much this might be in terms of cost to the chain. And when I'm talking about cost to the chain, we're talking about multiple things. We're talking about storage, like we referred to before, how much space it takes up on the on the servers. We're talking about processing speed, how quickly it processes, and also sometimes just other effects. Like there's different kinds of processing speed. There's like a short term, like it's just temporarily, it takes some CPU power, but sometimes some things you do have costs forever. So account creation is one that has a cost forever, because now all the accounts are never destroyed. So the more accounts we have, there's this section of the code that says, look, you give it an account name, and it has to find that account name. So the more accounts that are in there, the slower it gets a little bit. Now, it's not like it has to go through every one in order. We have, computer guys figured out a long time ago how to make these searches faster than that. So it's not one after the other, but it's still, the more you get, the slower it gets. So that's why these RC costs come in to begin with. So then, one of the things we've known for a long time is that those costs were set very arbitrarily and weren't always very good. So we spent a lot of time this time around doing an analysis to try to figure out, we made new tools that didn't exist before to start measuring the costs of the operations in a much more scientific way than we had before. So the things we measure, I'll just give you some examples. There's storage, there's CPU, there's long-term usage, and there's also memory. So how much memory your node needs is also dependent on. So these different buckets, and that's kind of the way the whole RC system works. It calculates those things, and it's dynamic. So the actual cost is not fixed for an operation at all times. It depends on how many people are using a resource. So if there's some resource that's getting tight at a time, like network traffic, there's a lot of people doing stuff. operations will go up in cost depending on how much they use the network or CPU, same kind of thing.
That's cool.
So in terms of the impacts, in some sense, every operation's got new costs because they've been recalculated using these automated tools. And specifically, one of the biggest things we noticed when we did all this calculations is, so there's, I guess you could say in processing of an operation, there's two kind of really big things. One is processing, do the operation itself, but there's other thing that's common to every operation, and that's called signature checking. And what signature checking is when you do an operation with your account, somehow the blockchain has to know that you did it and not someone else impersonating you. And so you're all familiar with, you have your keys, right? You have your posting key, and that basically what you do with your keys, you sign your operation so that the blockchain can check that signature and say, that's you, and that's not somebody else, and that's how it knows it's a valid operation to do with your account. So someone else can't spend the money in your account because of the signature checking. And what we found when we went in to look at the code was that by some sort of oversight in the original design, they didn't do the costing for the signature checking, which is one of the most expensive operations in processing most operations, is the signature checking. So this is going to sort of, I would say, equalize in some sense the cost of operations, because before, for instance, custom JSON, if you ignore the signature checking, seems very cheap because custom JSON, the blockchain node doesn't do anything with it except check it's valid JSON. It just, that's valid JSON. I don't care what it does. I don't care if this is doing a Hive engine transfer. I don't care if this is playing Spinnerlands. I don't care if this is a speak node operation. It just doesn't care because that's all second layer. But it does do the signature checking at the first layer. And so now that we're costing for those signature checking, you can guess custom JSON is going to go up relative to how cheap it was before, because it was just really, really cheap to what it should have been. And so as many of you may or may not know, 90% of the operations on the chain are custom JSON. So that sense is going to be a big deal for anybody who's doing custom JSON. We're only going to have a feel for exactly what the costs are, though, once we see it. We can see it on some on the mirror net, but some of this is also behavioral patterns, so we'll kind of see how it goes as it goes. So that's kind of the answer.
It's interesting you're saying that actually when more people are using custom JSON at the same time, it would also be. You said it was dynamic,
it's not so much custom
right?
JSON. It's
no. But I mean,
it's absorption of a particular resource. So we have these buckets of resources like CPU, bandwidth, storage. So if one of those, basically the system is like measuring how much of those things are being used. So when it sees an increase in one particular resource, so when you calculate the cost for an operation, it does some math based on each of those buckets,
right.
And it has a category of how much each of those an operation costs in each of those buckets. So that's how prices change. So it's not really easy for a human to compute those costs. So you can ask the chain as well to what the relative cost is right now.
Can we get a dashboard that shows those costs in real time? It's Brian of London again.
I think somebody actually had one. It seems like
we had one initially, but I think it no longer exists. But it was the guy who made BeamPy had
Holger.
Holger had something going on, which showcases basically some of the biggest costs. And coming back on the buckets and why the price are like dynamic, it goes back to the scaling. Is to make sure that we always allocate basically the same amount to all. I mean, not everything has the same cost, but we want to allocate a certain amount of cost to each operation. And so if one operation starts to cost a ton of CPU and everyone wants to have more CPU time, therefore the cost of this the bucket will be emptied, and therefore the cost of this operation will skyrocket because we no longer have enough CPU time, let's say.
Yeah, so just to be clear, it's not just that one operation. It's anyone that's using a lot of CPU is going to go up in cost.
And so that's one of the reasons why RC allows us to scale pretty well. It's because everything is dynamic, and instead of being like a very specific cost, it's everything moves with the chain. And that's the reason why blocktrades and team updated most of the costs. It's to more meet the expectation and the real life use cases.
Yeah.
Cool. Thanks. Thank you. Any more questions? You can catch a catch box. That's cool. It's already half. Oh, daar komt hij.
Good throw. Good throw.
Somebody wants to ask a question, or are we cool with the blockchain? how it is. Yes? If that's the case, really, yeah, I want to thank the guys on the stage. And we wrap up a little bit early. Thanks a lot, Martin, howo, and blocktrades, Dan. Thank you very much. You'll be here around, so if you have some feature requests.
Yeah, sure.
Please no.
How are you?
Feel free anytime. Come up.